We have an oil-based economy. We absolutely do have an oil-based economy. The amount of energy in a cup of oil is so great that it's very hard to compete with oil using animal power and even people power, and that is a major issue. We need to be converting into other high-density fuels rather than fossil fuel. And biofuels do have a high level of density and are very acceptable as a replacement.
It's a scientific fact that we are carbon-based life. The bodies of all animals and all plants are built primarily from variously arranged molecules of carbon, hydrogen, and oxygen. Almost all energy in the food chain originates as sunlight. Using solar energy, plants synthesize carbohydrate food out of carbon dioxide from the air and water from the soil in a process known as photosynthesis. So plant leaves function like solar panels, and the plants themselves are like batteries storing chemical energy captured from sunlight. When other life eats the plants, the chemical energy is carried down the food chain. As organisms metabolize carbon-based food, a portion of the carbon is oxidized for energy and carbon dioxide exhaled. Everything that lives, grows, and dies becomes food and recycles carbon. This is the carbon cycle. This graph charts carbon dioxide levels, also known as CO2, in the atmosphere from weekly measurements recorded by scientists since 1958. The reason why this graph is rising is due to the burning of fossil fuels, which overwhelms the carbon cycle with ancient carbon, overloading the atmosphere. The annual carbon cycle also leaves its footprint in this graph. The zigzag shows the annual pumping of carbon dioxide in and out of the atmosphere as plants grow in the spring and summer, and dead material decays in the fall and winter. If it weren't for our overuse of fossil fuels, the graph would look more like this. It would still zigzag, but it wouldn't be rising like it does now because there is an almost equal exchange of carbon in and out of the cycle. We can think of the carbon cycle as nature's economic balancing of the carbon budget. But we have overdrawn Earth's fossil carbon bank and created a surplus of carbon dioxide exhaust. CO2 is a greenhouse gas. It lets sunlight in, but reflects most radiant heat back to the Earth. Too much CO2 in the atmosphere traps in too much heat. The graph, interestingly, illustrates both a problem and a solution. The problem is the rise in atmospheric CO2 due to the burning of fossil fuels, and the solution is that we could use the incredibly dynamic CO2 pumping action of the natural carbon cycle to capture carbon and store it in the soils. By working cooperatively with nature, we can begin healing the planet. Annually, 120 gigatons of terrestrial carbon is captured through photosynthesis. Half of that transpires from the plants back to the atmosphere as CO2. The other half becomes biomass plant material, adding 60 gigatons to the 550 gigatons of the global terrestrial biomass pool. Every year, an equal amount exits the global pool as dead leaves and dead wood decay. Extracting a small fraction of this annual 60 gigatons of dead biomass could replace all our needs for crude oil through a chemical process known as pyrolysis.
Pyrolysis in layman's terms is best described as a process using heat in an oxygen-depleted environment to convert biomass into carbon, volatile vapors, and gases, and those vapors and gases can then be condensed into oils, and the carbon will come out as biochar.
Biochar is a carbon solid which is very similar to campfire charcoal. Biochar is extremely porous and has a unique natural ability to absorb nutrients and moisture, making it a very useful and powerful soil conditioner. It fixes inert carbon in the soil for thousands of years, keeping it from returning to the atmosphere as CO2.
So you essentially produce an emission-free technology that satisfies the need for biofuels as well as to sequester vast amounts of carbon.
Biochar has an incredible track record for rejuvenating unhealthy soils. It helps keep in nutrients, mitigating nutrient runoff pollution into streams and rivers.
How biochar affects agriculture and forestry is actually very profound. From an agricultural point of view, when you add carbon to the soils, you absorb outgassed CO2, nitrogen, methane, and in addition, you provide living space in the pores of the biochar for enormous amounts of microbes, which return fertility to depleted soils, and the absorption capability of the biochar also will hold water for extended periods of time, allowing for less irrigation, particularly during droughts. In a forestry situation, pyrolysis and biochar enables us to take forest waste, convert it into carbon and fuels, and return that carbon back to the soil in forests to increase biomass production and therefore CO2 absorption from the atmosphere.
Biochar-amended soils produce thriving, fertile benefits lasting thousands of years. So biochar is an excellent carbon investment that pays off our fossil carbon debt while also providing a lasting legacy of thriving fertility for many generations of our descendants to enjoy.
So in how to transition from a fossil economy to a bioeconomy, the fossil fuel industry pushes back against a bioeconomy. Therefore, if we include them in by transitioning them from refining fossil fuels to refining biofuels, it does not threaten their survival, it doesn't threaten their profits, and in addition, the oil that they don't use can be used for other products that don't emit CO2 into the environment. If we can move into an economy based on adequate profit, sustainable growth for the good of all, then we can back off on a lot of this excessive industrial activity that isn't necessary. And we can begin to use these amazing technologies that we have around us for the good of all, as opposed for the good of a few people.